The aim for today's experiment is to determine the energy band gap of a semiconductor by four-probe method. In order to open this experiment virtually, we'll have to click onto this link, that is vlab.amrita.edu. Once we click onto this link, this particular page will be opened up. Please click onto the physical sciences portion. In the physical sciences portion, the list of all experiments which are included in physical sciences will be displayed. Now, since our experiment is four-probe method and this experiment is included in the solid state physics lab, so we will be clicking on the solid state physics virtual lab, in which we'll be able to see the list of all experiments included there. So the list of all experiments included here are these. So I'll be clicking on to the resistivity by four-probe method. Once I click onto this, the very first tab that we are able to see is the theory tab. This includes the aim, apparatus, theory, and the applications of this particular experiment. In it, if we see, the apparatus completely includes an oven ranging from 0 to 200 degrees centigrades, a constant current generator, oven power supply, and digital panel meter which measures the voltage and the current value, a sample which is in the form of a thin wafer, and a probe arrangement. Now, since this probe arrangement consists of four probes, that is 1, 2, 3, and 4, which are mounted on this thin wafer of semiconducting material, that is why this experiment is said to be the four probe experiment. Out of these four probes, the inner two probes, that is probe number 2 and probe number 3, are used to measure the voltage. However, the probe number 1 and probe number 4 are connected to a constant current supply. Now, this constant current supply directly tells us that in this particular experiment, the value of our current is going to remain fixed. Now, for every experiment, the theory of the experiment can be read about under the theory section. For this particular experiment of ours, the main equations in order to calculate the resistivity first will be second and the third equation. The second equation is resistivity is equals to rho naught upon function of W by S. Whereas if we calculate the value of rho naught and substitute it here in the second equation, then we'll be able to calculate the resistivity of our semiconducting material. For calculating rho naught, we'll have to make use of the equation number 3, that is V by I into 2 pi S, where S is nothing but the spacing between the probes in meter. And the spacing between all the four probes is equal, and it is usually around 2 mm. So the value of S, that is the spacing between the probes, as well as the function of W by S will be provided to you by the manufacturer itself. That is why you don't have to calculate those values on your own. Now, once we are able to calculate the resistivity, then we can calculate the energy band gap for that particular experiment. The second tab is the procedure tab. If we click on to this procedure tab, this will be guiding us through two procedures. That is, one is for the simulation that we'll be performing online, and the second procedure is for the real lab. If we go on to this entire procedure, then it will be very easy for us to perform our experiment both on the simulator as well as in the real life. After taking your readings from the simulator, we'll have to plot an observation table, make necessary calculations, and then we'll be able to get the final result of our experiment. Fine, but since in this particular tab we are only guided through to calculate the resistivity by the four probe method, therefore I'll be sharing with you this particular PDF. So this is how you will be performing your experiment. First of all, you will be writing down the value of the current which you will be fixing. Then the observation table will include the temperature in Kelvin, the voltage that you will be measuring in your experiment in millivolts. Then you will be taking down this 1000 by T. Then you will be calculating the resistivity by the formula V by I into 2 pi S function of W by S. The value of S is already provided to you, and the function of W by S value has also been already provided. value of I you have from the constant current source, and for V you will be calculating those with for every value of temperature. So we can calculate the value of resistivity at all the temperatures. After that we will be taking the log of this resistivity. Now, once we calculate the resistivity value, we can take down its average and get the resistivity of the semiconducting material. However, our aim is to calculate the energy band gap. So for this, we have to plot a graph between log rho and 1000 by T. Once we plot the graph for these two things, we will be getting a straight line. Now from this straight line, we'll have to calculate the slope of this particular graph, and then we'll be using the slope in this particular formula. EG stands for energy band gap. This is equivalent to 2.303 into 2 into Boltzmann constant into slope into 1000. If we multiply all these factors together, then we'll be getting the value of our energy band gap in electron volt. Now here the value of Boltzmann constant is to be substituted in electron volt per Kelvin and not joules per Kelvin. So for that the value of Boltzmann constant is 8.6 into 10 raised to power minus 5 electron volt. So we'll have to use all those values, and then we have to plot this graph, and this is how we will be able to calculate the energy band gap of our semiconducting material. Now, before further ado, let me directly open up the simulator and explain you the experiment. Just click on to the simulator tab. Let me make it on to the full screen mode. See, here is the experimental setup. This particular thing, this is the constant current source, and this will be displaying the value of the current that you will be fixing for your experiment. On the right hand side, you can see a microvoltmeter which will be displaying the value of the voltage with change in the temperature as soon as you turn on your oven. Here this is your oven, and in this, if I go on to this cross section portion on the right hand side, you'll be able to see that yeah, there is a chip, and then there are 4 probes attached to this particular setup. The inner 2 probes will give you the value of voltage which will be displayed here, and the outer 2 probes will be giving you the value of the constant current source that you have fixed, which will be displayed here. And this oven is attached to a constant this oven is attached to a power supply source for making it get heated up. So this is how you can see the cross section. Now the very first thing is to select the material. If we click here, then you will be able to see 2 options. Now since our experiment is to find out the energy band gap for germanium, therefore I'll be clicking on the germanium portion. After that, you can fix the range of the current for the 2 things. If you fix on 20 milliamperes, then I'm so sorry. If you fix on 20 milliamperes, then you will be able to see that this slider bar is from 1 to 20, but each value will be varying from 0.2 milliamperes. So if I click on to this, then the next value from 1 will be 1.2, then 1.4. So it will be varying in 0.2 milliamperes interval. Fine. However, if I click on to the 200 milliamperes portion, then in this the values ranging will be, difference will be 2. So the first value is 1, the second one will be 3 milliamperes. Then it will be 5 milliamperes, then 7. So this is up to you what range you want to choose. For my experiment, I'll be choosing 20 milliamperes range. Okay. Now this is the range of the oven. For this range of the oven, you will be able to see the difference here in the temperature. If I choose into 1, the range of the temperature is from 25 degrees centigrade to 95 degrees centigrade. If I choose into 10, then it is from 2.5 till 20. So I'll be choosing here into 1. Now there are 4 buttons. First of all, we have to click on to the set button. When we click on to the set button, then we have to slide our cursor onto this panel and fix the maximum temperature that we want our oven to go to. So I'll be wanting it to go to 95 only. So I'll be clicking on to this slider and making it 95. So this is where I want my oven to go from 25 to 95. Therefore, I have fixed it for 95. If you want it to go till 70, then you can fix it till 70. If you want to go to 80, then you can fix it till 80. For my experiment, I'll be fixing it on to 95. Now, once you do that, you also have to select the range of the voltmeter. So if I select 1 millivolt, then I am seeing a 0 0. It means that the value for my voltmeter is out of this range. So I'll have to move on to a bigger range. I'll be moving on to 10 millivolts. Again, I'm not getting any values. It means that I need to increase the range for my voltmeter. So I'll be going on to the 100 millivolts. Now if I go on to the 100 millivolts, then I am able to see some values here. So that is why I'll take on this range as the fixed range for my experiment. Now in current, I'll be setting the fixed value of current. You can set it to any values from 2, 3, 4, 5 as per your wish. For my case, I'll be taking the values to be 3 milliamperes. So this is the current that I have fixed for my particular experiment. The oven has been set to the maximum temperature that I want. The range of the voltmeter has also been decided. So now what we have to do is we have to click on the run button. Once I click on the run button, the temperature here will be the room temperature, that is the current temperature that was initially present in the oven. So it will be 25, and as soon as I click on to the run button, the temperature will start increasing. See, 26, 27, 28, 29, 30. See, now I want to record the value at 30 degrees Celsius. So what I'll do, I'll click on the wait button. What the wait button does is it stops the oven from increasing its temperature further. So now what you can do is you can make a column of temperature and a column of voltage. So I can record at 30 degrees Celsius, the value is 84.65. Then I'll run the temperature, let's say for another 5 degrees centigrade increase. Now again I'll click on to the wait button. So now corresponding to this particular temperature, this is the value of the voltage. So I have recorded it now, so I'll click on to the run button again. So again I'll be waiting. So this is how you have to record your temperature and the corresponding voltage. You can also click on to the measure button. So this will also help you measure the particular value, and then you have to click on the run button. So again the temperature will start increasing. Again you can wait, and then you can record your temperature. Then again you can run. So this is how you will be performing your experiment. Now once you have done your experiment, then you can close this tab, or if you want to perform your experiment again, then you can click on to the reset button. Once you click on to the reset button, everything will come back to the initial value, and then you can start your experiment again. So this is how you will be performing your experiment in the simulator portion. Now let me show you the observation table again. See, this is here you will be recording your temperature. On the oven it was represented in centigrade, so you'll have to add 273, and then you can write the observation table for temperature in Kelvin. Here you can write the value of your voltage. Then again you can do the make these columns as well, and then you have to plot the graph with the third and the fifth column in order to get its slope, and substitute the value of the slope in this particular formula to get the energy band gap of the semiconducting material that you want to use. Now if you move on to the reference tab, in this reference tab you can get a list of books and some links where you can go on and study this experiment furthermore. These are basically your references. And in the assignment portion there are certain things that you can do. However, your teacher will be guiding you whether you have to perform these experiments or not, these assignments or not. But for the present scenario, all you have to do is you have to study the theory, you have to go through the procedure, then move on to the simulator, take down your readings, make your calculations, and evaluate your result. Now, as for the self-evaluation tab, once you have done everything that has been suggested so far, then only you should move on to this self-evaluation part. This self-evaluation part consists of the questions regarding your experiment. In it you can just check the knowledge of you as to how far you have understood your experiment, and this will also give you a gist of how the questions can be asked to you regarding this particular experiment. So that's it for the video. Thank you everyone. Thank you.